All right, so how do we calculate the standard error of the difference in means? Well, here's the formula that I've written on the board here for you. And so it's the square root of what we call here the pooled variance. This is the pooled variance multiplied by 1 over the sample size of group 1 plus 1 over the sample size of group 2. And so we need to know then the formula for the pooled variance, and I'll write that up here for you. So it's the degrees of freedom for sample A multiplied by the variance of sample A, plus the degrees of freedom for sample B multiplied by the variance of sample B, divided by the degrees of freedom of sample A plus the degrees of freedom of sample B. And so the way to think about this is that what we're calculating here is a weighted average of the sample variances. So if there's if we have different sample sizes, for example, then we're going to be weighting the pooled variance depending on the different sample sizes. Okay, and then so for our example, if you did this calculation where you know the degrees of freedom and the variance, we can plug that all in into those values, and in our example, the pooled variance is going to be equal to 362. And so in that case, it's actually just the average of the two sample variances because we have equal sample sizes. And so now that we have that, we can compute our standard error of the difference in the mean using this formula here. And so the standard error of the difference in our two means of sample A and sample B is going to be the square root of 362, which we have from here, multiplied by 1 over 7 in this case, which is our sample size of group 1, and 1 over 7, which is the sample size of group 2. And a common error here, just to alert you, is that this is not the degrees of freedom, this is the sample size. It is the sample size, and so try to avoid making that mistake. So if we do this computation now, we're going to get a standard error of the difference of means of 10.16. And so now we can compute our t-test statistic because we have all the numerical values that we need. And so let's do that quickly here. Get rid of this. And now remember that our t-test statistic is simply going to be the difference between the two sample means that we've measured divided by the sample error of the difference in the means, which we write like this. And now this is going to be 147 minus 131. That was the two means divided by this value 10.16. And if we do that calculation, that is going to be 1.57. And of course, now that we have the t-test statistic, we have to go and consider what's the probability of getting a test statistic that large or larger when the null hypothesis is true. And in order to do that, we need to know which t distribution to look at, which varies as a function of the degrees of freedom. And the degrees of freedom for a two-sample t-test is going to be equal to the sample size of sample 1 plus the sample size of sample 2 minus 2, since we've determined the two means. And so in that case, we have 12 degrees of freedom. And so now we can go and look at that distribution. And let's clear the canvas here. And let's see what that distribution would look like. As with all t distributions, it's going to be a symmetrical distribution around 0. This is t-test distribution for 12 degrees of freedom. We now go and look at our t-test statistic value, which is 1.57. And so we want to consider this probability of getting 1.57 or larger. And given that we're doing a two-sided t-test, because our null hypothesis is simply that there is a difference in the mean, we also need to look on this side and add these two probabilities. And so the p-value is going to be equal to 2 times the probability of t being larger than 1.57, which in this case is equal to 0.14. And so in this case, you would not be justified in rejecting the null hypothesis because we have a t-test statistic that is going to occur with probability 0.14, or a t-test statistic that large or larger, given the null hypothesis is true. And so that's a pretty, reasonable probability. We'd expect it to happen more than 1 time in 10. And so we are unable to reject the null hypothesis. And so this is an interesting contrast to our paired t-test design, where we had exactly the same data, but in that case we had pairs of individuals, and we were looking at the differences between those values. In this case, we do not have pairs of individuals. We have sample 1, sample 2, and in this case, we have a insignificant t-test statistic. And that is the 2-sample t-test.